Okay, so very similar to yesterday with one additional step. And that is I have two radicals being multiplied together. So my first move is to multiply those inside numbers to get a new inside number and then break it down. So remember yesterday when we did this, we did repeated division. And I just started with the smallest number bigger than 1 that can go in. I just work my way up. I start with 2 and I keep dividing by 2 until I can't divide by 2 anymore. I can divide by 2, then I stop, then I get 45. So 45, I can't, it's not even, so 2 doesn't go in. I'll try 3. 45 divided by 3, 15, and then keep going from there. I'll do 3 until I can't go anymore. And then once I get to a number that's primed, you guys remember prime numbers, only divisible by 1 in itself. So that would be 5, prime number, yep. So once I get to a prime number at the end, 3 doesn't go into here. The only number that goes into 5 is 5. And that doesn't get me anywhere, 5 and 1, so I stop there. And then I take my pairs. For every pair, 1 goes out. And then whatever's left goes in. Doesn't matter if I do 5 times 2 or 2 times 5. And then I just clean it up or finishing up by multiplying those things together. So final answer, 3 times the square root of 10. So start by multiplying that and then break it down from there. Now, some problems are going to be a little bit different. If we look at problem number 2, notice that there's a 4 in front. The 4 will remain in front. That 4 is in front of the square root of 3. That 4 is not inside of this radical, these square roots. It's outside of it, so it has to remain outside of it. And then I'll multiply 2 times 3 to get 6. And then when I do my repeated division on 6, I start with 2, I get 3. Notice I don't have any pairs. Because there are no pairs, this ends up being the simplest form. That was an easy one, not so bad. It was in, the radical part ended up being in simplest form even after I multiplied it. So what happens if there's multiple numbers in front? Even if they're negative or positive, it doesn't matter. I'm going to start by moving those. Negative 3 times negative 5. And then times the square root of 20 times 5. So I'll multiply the numbers that are out, and I'll multiply the numbers that are in. And then I can break that down with my repeated division. Some of you might recognize 100 as a perfect square already. Remember, one thing that you can do right away is to check, can I take the square root of the number that I'm looking at there? And if you can, that perfect square, I know that that is 10. If you forgot that and did your repeated division, you'd get 50 and 25 and 5 and 5. You'd end up with a pair of 2s and a pair of 5s. So if you don't catch it, you're not going to ruin it or anything. It'll be fine. But this ends up being 15 times 10, or 150. So my final move is to blend those together. Keep the outsides out and the insides in until that final end part when you break it down. Up next, number 4, I do not have any outside numbers, so I'll do 20 times 20, which is the square root of 400. And I'll go ahead and check and see if that's a perfect square. Again, some of you might foresee the answer to this question right away. Some of you might not. Depends on your math skills. Square root of 400 is 20, came out as a perfect square. That becomes my answer. This is something to be on the lookout for. When you multiply a square root by itself, it just drops the square root. Square root of 5 times the square root of 5 is 5. Square root of 3 times the square root of 3 is 3. So be on the lookout. If you remember those things, the more you remember as you do math, the easier the math gets and the quicker you can come up with more shortcuts. Okay? All right, we have 2 more to try. This one is -5 times the square root of 20. I'm speeding up the process a little bit. Are we okay with that?
Yeah.
That looks good. I just did 2 times 10 to get the 20. Now I'll check to see, is 20 a perfect square? Second square root of 20. If it comes up as a decimal, which this one did, I know it's not. So then I will take the 20 onto the side and I'll do my repeated division. I can divide 20 by 2, I get 10. I can divide 10 by 2, I get 5. So for every pair I see, 1 goes out. The -5 is still there, so I'm just bringing that -5 down. This 2 is from my pair of 2's over here. And then what's left without a pair is the square root of 5. And one final step. For my final answer. So again, keep the regular numbers separate from the radicals until you do the breakdown, until you pull out the perfect squares. So our last problem here, we have a negative in front, so I'm just going to bring the negative in front there, and then I'll do the 15 times 5, which is the square root of 75. And then off to the side, I'll do my division. Does 2 go into 75?
No.
Does 3 go into 75?
Yeah.
Yeah. Does 3 go into 25?
No.
Does 5 go into 25?
Yeah.
Notice how I'm working my way up. Can I put anything more into 5? No. So for every pair, 1 goes out. I bring the negative down, put the 5 after that. Whatever's left without a pair goes in. So again,